So we want to draw this function, and we want to figure out what's going on at x equals 1. Because we have at x equals 1, we have a restriction. Here we're dividing by 0. So we want to know what's going on. So we can use a limit to do this. Okay, so if we have f of x, the limit of f of x as x goes to 1 of f of x. So what we can do is we can see if we can get rid of that divide by 0. Okay, so we're going to do this algebraically then. So we're going to see what's happening as x goes to 1. Well, we can simplify it algebraically here. Okay, and then see if we can evaluate the limit at x equals 1. So at x equals 1, when I plug in x equals 1, we end up with a value of 2. And it's a two-sided limit, so it does have a limit. So if the limit equals 2, so at x equals 1, we know we have a y value of 2, but it's a restricted value, so we know that must be a whole. Okay, so it's got to be a whole at 2. So drawing this function, really this function then is going to behave like a linear function. Okay, y equals x plus 1. And as it hits x equals 1, we're just going to have a whole. And if we're to draw how it's defined at x equals 1, it's defined as x equals 3. Okay, so we have in here a removable discontinuity. Okay, so is this function continuous for all real numbers? No, because if I draw this, I have to lift my pen up. So this is not continuous for all real numbers. Okay, so we can use limits here then to describe these wholes, and we can check for continuities based on these limits as well.